Rational variable expression is also known as RVEs. A rational variable expression is when you have a polynomial over top of a polynomial. Okay? When you have a polynomial over a polynomial. That is what a rational variable expression is. RVE. It follows the same rules as fractions. There are 4 rules to fractions. Simplifying, multiplying, dividing, and adding, subtracting. Here's an example of each. Wow. Like really bad, because like that's pretty straight. And this is just terrible. All right. So, fractions you've been doing since like grade 5. So it's the same rules of fractions that you've been doing since grade 5. Okay. Simplifying. You can never leave a fraction like this if you can reduce it. So you must reduce. If you have 16 over 12, again, we've been doing this one today, you can divide by 4 on both the numerator and the denominator. So you get, if you divide by 4 here and divide by 4 here, you get 4 over 3 is your answer. So for fractions, you must always simplify if you can. If there are any greatest common factors, like 4, in the numerator and the denominator that you can divide out, then you have to do it. Multiplying says that you multiply top to top and bottom to bottom. But before you do that, you have to see if you can cross cancel. That is, take a greatest common factor from a numerator and a denominator. So for example, here, 16 over 24 has a greatest common factor. You can reduce between 16 and 24. You can divide them both by 8. So I will slash out the 16 and the 24 and put 8 here. Or sorry, that was terrible. You're dividing by 8, so 2 and 3. Here, between 35 and 25, you can reduce again. You can divide them both by 5. So 25 divided by 5 is 5. 35 divided by 5 is 7. Are you fully reduced? 2 over 7 doesn't reduce. 2 over 3 doesn't reduce anymore. 5 over 7 doesn't reduce. 5 over 3 doesn't reduce. You cannot reduce across. Okay? It has to be between a top and a bottom number. So now that there's no more reductions, you multiply. 2 across, so 2 times 5 is 10. 7 times 3 is 21. The rule for dividing. Dividing says that when you divide, you have to multiply by the reciprocal. You have to flip the second guy. So if you flip this, it becomes times now, 33 over 15, but this does not change. And you reduce again, because now you're following the rules of multiplication. Where can you reduce? Well, 22 and 33 have 11 in common, so that reduces this down to 2 and this down to 3. 3 and 15 reduce. They can both divide by 3, so 1 and 5 is what you're left with here. So now you can't reduce between 1 and 2. You can't reduce between 3 and 5. You can't reduce between 1 and 5, and you can't reduce between 3 and 2, so you're done. You get 3 over 10. Okay. And likely the hardest of fractions is adding and subtracting, because you have to find a common denominator in order to subtract or add. A common denominator is also known as the least common multiple. It is the lowest number that both 6 and 4 can go into. Okay? It's the lowest number that the two denominators can go into. What's the lowest number that both 6 can divide into and 4 can divide into? It's, 12, that's right. 6 goes into 12 how many times? 2. So it's like you have to take this 6 and multiply it by 2. 4 goes into 12 how many times? 3. So it's like you have to take that, you have to multiply both the top and bottom to 3. You cannot multiply the bottom by 3 and not the top. That gives you, now back in grade school, this is what you would do. You would write it like this. You'd multiply. You'd get 2 over 12 minus 9 over 12. Okay? I don't like this step. It's not helpful for RVEs, I find. It's better to think of it as to write it over one denominator, like this. So 2 minus 9 over 12. But if you really like this way, you can. It's just more writing. And then you get 2 minus 9, which is, of course, negative 7 over 12. So that's how you do RVEs, or that's how you do fractions. Now let's apply those rules to rational variable expressions. The first rule to simplifying an RVE is factor everything in sight. So let's go factor the numerator and denominator. That's what my grade 11 teacher used to say. So you factor every numerator and denominator. Then follow the rules of fractions. I can erase. Ooh, I forgot a step. Sorry, guys. State restrictions. Yikes. Yep. Bless you. All right. So say that I was doing simplifying. simplifying. What if I gave you x squared minus 3x plus 2 over 2x squared minus 8? You have to be tremendous factors in order to do RVEs. When you factor off to the side, and you write your answer in. You should not, your next line underneath this should have your factored version fully. It should not be your work. So you factor off. I don't give any marks for factoring on RVEs. So you factor this off to the side somewhere, and then you write your answer in. So if I was factoring x squared minus 3x plus 2, that is what kind of factoring? It's an easy trinomial where you have to find two numbers that multiply to 2 and add to negative 3. So off to the side, this will factor to x minus 2, x minus 1. Again, you do not get any marks for this, so I don't care whether I see it or not. If I ask you to factor 2x squared minus 8, what kind of factoring is that? Difference of squares? Kind of. Hello? What? Yes, you can common factor. You always common factor first if you can. So you can common factor a what out of this? Yep. So you take out a 2. You're left with x squared minus 4. Now, mocks, it's a difference of squares. What's the answer? Careful. X plus square root it. So square root of 4 is 2. You got to think that this times this has to make that. Yeah. Okay? So I write that in. So the first step is just to factor everything you can. Okay. Then you state restrictions. So what is a restriction? Yeah. But what is a restriction? What you have to state before that, you have to state what your restrictions are. A restriction is a value that makes the denominator 0. You are not allowed to divide by 0 in math. So you have to tell me what you cannot be to prevent a 0 from happening. To do that, you set each factor not equal to 0 and solve it. So off to the side, x plus 2 cannot equal 0 because x cannot equal negative 2. So you take each factor that has an x, you set it not equal to 0, so like the other one is going to be x minus 2 cannot equal 0, so x cannot equal 2. I'm just solving by moving this to the other side. Okay. So for that, right, I get x cannot equal plus or minus 2. Okay. So those are your restrictions. Again, think about if you put negative 2 into here, negative 2 plus 2 is what? 0. That means that the whole denominator becomes 0, because once you multiply it by 0, then it's all going to be 0. And if you type in divided by 0 on your calculator, you get an error, because you cannot divide by 0. Okay? So now that I've stated my restrictions, I can follow the rules to simplifying, which is that you see if you can cancel anything out of the numerator and denominator. You can cancel the x minus 2. So you're left with x minus 1, 2, x plus 2. That's your answer. We'll do one more simplifying. Let's do let's go 3xy minus 6x squared y. And then on the top, let's go 2x squared minus 3x plus 1. All right. Let's factor off to the side. So 2x squared minus 3x plus 1. What kind of factoring is that? Yep. Yeah, hard trinomial. You have to find two numbers that multiply to what? 1 and add 2. 2, very good. Good. Those numbers are -2 and -1. Using the ratio method, we write 2, the leading coefficient, over top. And we reduce if we can. So this reduces to 1 over -1. So this and this, those are our ratios. The numerator factors to x minus 1, 1x minus 1, and 2x plus 1. 1x minus 1, 2x plus 1. The denominator is 3xy minus 6x squared y. We'll factor off to the side and write the answer in. Okay. What are you going to do here? First step to factoring is put it in descending order. This has a degree of 2, this has a degree of 3, this has to come first. Okay? Then we can common factor. What do you common factor out? A -3xy. The first term is negative, so we have to take out a negative. And you're left with 2x minus 1. Shoot. What happened here? Here. This should have been a -1. My numbers were -2 and -1. Right? So that means that this should have been 2x minus 1. Sorry, guys. So now when I write this in, I get -3xy, 2x minus 1. I copied the number wrong here. Okay? You asked me, Mox, earlier, you said, why do I have to common factor out a negative? If you had not common factored out a negative, you would not have been able to cancel here. Because you would have had a negative here. And it'd be -2, which is not the same thing. So that's why. Okay? Now I'll state restrictions. So I'll do my restriction work off to the side. You set every expression, okay, everything in the denominator only, not from the numerator, from the denominator, not equal to 0. So x cannot equal 0. You can write -3x if you want, but then you're going to divide by -3, so you still get 0. Okay? Then I look at my next expression. Y cannot equal 0. And then my next expression is 2x minus 1 cannot equal 0. I can move the -1 to the other side to get 2x cannot equal 1. And then I get x cannot equal 1 over 2. Okay? So the restrictions are for this. Make sure you all got that. The restrictions are x cannot equal 0 or 1 over 2. Y cannot equal 0. And now I simplify. 2x minus 1 cancels from both the numerator and the denominator. Okay. 2x minus 1 cancels from both the numerator and the denominator, leaving me with x minus 1 over negative 3xy. But remember, the rule for rational numbers is you cannot leave a negative in the denominator. You have to move it to the top. Let's do multiplying, dividing. We're going to just do a dividing question because it involves multiplying and dividing. Here's my example. Let's go x squared minus 3x plus 2 divided by let's go x squared minus 4x plus 5. Okay. Then x minus 1, x minus 2, x minus 1 and x minus 2, x minus 1 and x plus 5. Let's just go. Sorry, this should be plus 4x and minus 5. X squared plus 4x and minus 5, right? Yep. And let's go. I'm going to cheat. X. Let's go here. X squared plus x minus 6. And here, let's go x squared plus 8x plus 15. You take that one. You take this one. Mox, you want to take this one? Yes, sir, you want to take this one? Liam and Nick, you guys can do this one. Okay. So factor. Yeah, this one. Just tell me when you're ready. You got yours? Negative 1 and 5. Good. X minus 1, x plus 5. Very good. Yep. Good. Anybody else? X plus 3, x minus 2. Yep. You're finding numbers that multiply to what, Hannah? You're finding numbers that multiply to, right? Yep, what are your numbers? Only so many numbers multiply to 2, right? So 1 and 2, but it has to add to negative 3? Yeah. So what are your numbers? It's minus 1 and minus 2. You can't, right? There's only so many numbers that multiply to make 2. Yeah. Right? Right, but so if you multiply to a positive, then they both have to be the same sign, right? Okay, so we're here. Our restrictions from this are, okay, when you set this not equal to 0, what can't x be here, Max? So if you set this equal to 0, don't tell her. See, if you set this not equal to 0, then when you move this to the other side, what can't x equal? When you solve for x here. When you move this to the other side, it becomes right. So from this, x cannot equal 1. Okay? How about this one, Isra? Yeah, can't equal negative 5. It's the opposite. Liam? What can't x equal here? Imagine this. That's fine. Just imagine this. So when you move this to the other side, what does it become? When you move the 3 to this side, it becomes? When you move it to the opposite side, it changes, right? Yeah, so x cannot equal negative 3. And we don't have to duplicate, because this one, when you move that to the other side, becomes negative 5. But we already listed it. Okay? Okay, the next step is, for dividing fractions is, yeah, you have to flip. So you get x minus 1, x minus 2, but you don't flip the first guy, you flip the second guy. Okay? But this creates a new issue. This is very, very, very important for dividing fractions, or dividing RVEs. What you did is, remember the issue is restrictions. You cannot be equal to 0 in the denominator. When you flip this, this moves to the denominator. This x minus 2 moves to the denominator, creating a new restriction. You cannot be 2 either. Okay? You cannot be 2, because now this is in the denominator. And now we can follow the rules to fractions for multiplying, meaning that you can cancel any factor that's in the denominator and the numerator. So, minus 1 and minus 1, gone. X plus 5 and x plus 5, gone. X plus 3, gone. X minus 2 and x minus 2, gone. Final answer is 1. No. Because when you divide these out, this divided by this is 1. When something is left blank up top, it's 1, not a 0. Okay? So that's how you multiply and divide fractions, or RVEs. This is the hardest. Okay? All right. Just walk in front of it. All right, so rules for adding and subtracting is you have to find a common denominator. But before that, you have to factor everything that you possibly can. So when I factor this, I cannot factor 3x, so it's just 3x. I can factor x squared minus 4. It's x plus 2, x minus 2. It's a difference of squares. I can't factor 2. But I can factor this. This is an easy trinomial. It's x minus 3, x plus 2. Okay? Now, this is the hard part. Figuring out what the common denominator is. The common denominator is the expression that each of these guys will be able to divide into. This denominator will be able to go into, and this denominator will have to be able to go into it. If this has to be able to divide into here, so if the x plus 2, x minus 2 has to be able to divide into here, then it has to be existent. It has to be present in the denominator. Otherwise, it cannot divide into it. So this has to be there, this has to be there. From this, is this denominator already here? Well, part of it is. This factor is, but this factor isn't. So now this has to go into here as well. So you throw the first denominator in, and then you say, is this here already? No, so I have to include it. Is this here already? Yes, so I don't have to include it again. Okay? That's how you determine your common denominator. And so you have to, what do you have to multiply this by to get from here to here? What's new from this denominator to this denominator? Hello? Yeah. Yes. You have to multiply by x minus 3. Now look at how the denominator here is the same as this denominator. But whatever you do to the bottom, you have to do to the top. What's new from here to here? So you have to multiply both the numerator and denominator. That. I don't really like writing these. I like to write it like this. We have not yet stated restrictions. From this, x can't equal negative 2. From this, x can't equal 2. From this, x can't equal 3. Those would create zeros, which you cannot have. When you add and subtract, you expand and simplify the top, but not the bottom. So you get 3x squared minus 9x minus 2x plus 4 over x plus 2, x minus 2, x minus 3. Instead of recopying this whole thing, notice, by the way, that that negative 2 distributed on the negative 2 to create positive 4. Instead of rewriting this whole thing when I simplify, I'm just going to erase. You guys can do that too. And just change this to minus 11x plus 4 instead of writing a whole new line. So this is your answer, and these are your restrictions. Okay? This takes lots of practice. On a further lecture, I'll probably do more examples, but it's getting a little late. Oh. Okay, now you can cut, yeah.